Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my channel. Our today's topic is overcurrent protection and it's part 2. Let me remind you, in part first we discussed the importance of overcurrent protection and the devices used for overcurrent protection. In this part we shall discuss the schemes for overcurrent protection. So let us start. There are various overcurrent protection schemes used in power system to ensure the safety and reliability of the electrical equipment and circuits. The schemes are as under: instantaneous overcurrent protection, definite time overcurrent protection, inverse time overcurrent protections. These protection schemes employ different techniques and devices to detect and respond to overcurrent protection. So first of all, instantaneous overcurrent protection. Instantaneous overcurrent protection relay operates without any time delay. If the current exceeds a preset threshold, the relay will trip immediately. This type of protection is typically used for a critical equipment that needs a rapid disconnection to prevent severe damage. ANSI code used for this type of the protection is 50. Next is the definite time overcurrent protection. The relay in this protection scheme is set to trip after a specific time delay, regardless of the magnitude of the overcurrent. In this type, two conditions must be satisfied for tripping. Current must exceed the setting value and the fault must be continuous, at least at equal to the time setting of the relay. So it has a time setting and pickup adjustment. The setting of this kind of the relay at a different location in the network can be adjusted in such a way that the breaker closest to the fault is tripped in the shortest time, and then the other breakers in the direction toward the upstream network are tripped successively with a longer time delay. So we can say the disadvantage of this type of the protection is that it is difficult to coordinate and requires changes with the addition of the load, and the short circuit fault close to the source may be cleared in relatively a long time in spite of its highest current value. It is often used a main protection for outgoing feeders, bus couplers. Definite time overcurrent relay is used as a backup protection of a distance relay in a transmission line with a time delay. Backup protection to differential relay of a power transformer. The next one is important one, that is inverse time overcurrent protection. This one is the most common protection scheme. It uses relays that operate based on the principle that the time it takes for a relay to trip is inversely proportional to the magnitude of the current. This means the higher overcurrent level will cause the relay to trip faster. The inverse time overcurrent relays are also referred as inverse definite minimum time, or we can say IDMT. They are available as a standard inverse, very inverse and extremely inverse characteristic. The operating time of both overcurrent definite time relay and overcurrent inverse time relay must be adjusted in such a way that the relay closer to the fault trips before any other protection. This is known as a time grading. The adjustment of the definite time and inverse time relays can be carried out by determining two settings. One is the time dial setting and other one is the pickup setting. The time dial setting adjusts the time delay before the relay operates whenever the fault current reaches a value equal to or greater than the relay current setting. The tripping characteristics for a different time multiplier setting using IEC 60225 are shown as for the standard inverse, very inverse and extremely inverse. Pickup setting is used to define the pickup current of the relay by which the fault current exceeds its value, and it is determined as where KID is the overload factor, I nominal is the nominal rated current, and CT stands for the current transformer ratio. A figure with a type of inverse time characteristics is shown. As we can see from this, the very inverse curve is much steeper and therefore the operation increases much faster for the same reduction in the current compared to the standard inverse curve. Very inverse overcurrent relays are particularly suitable if there is a substantial reduction of the fault current as the distance from the power source increases. With extremely inverse characteristics, the operation time is approximately inverse proportional to the square of the applied current. This makes it suitable for protection of a distribution feeder circuits in which the feeder is subjected to peak currents on switching in, as would be the case on a power circuit supplying a refrigerator, pumps, water heaters, and so on, which remains connected even after a prolonged interruption of a supply. So, summarizing that, inverse time overcurrent protection provides a good coordination between a protection devices and used to protect a range of devices from small appliances to large generators. So that's all from today's session. Hope this will be very useful for you. So please like, share and subscribe my channel. Thanks for watching.